In this game that I'm working on, you play as a dragon, and I want my dragon to be able to run on the ground, jump. If I jump in the water, I want to be able to float to the surface and then swim along the surface. I want to be able to dive and swim underwater. I want my dragon to move in the direction that I'm looking in, including going up and down. If I'm done swimming underwater, I want to be able to float to the surface. And I want to be able to fly, of course. When flying, I want to move in the direction that I am looking in, and I don't want Unreal's default inertia because that looks like annoying sliding in the air. When I'm flying up, I want to go slower to mimic the effort of the dragon beating its wings against gravity. When I look down, I want to go into a dive and gain speed. If I pull up, then I start slowing down. I want flying locomotion in my game to have a roller coaster feel to it. I want to feel the freedom of flying. In this video, I am showcasing my solution and explaining what I did. This isn't a follow-along tutorial, and I'm not teaching Unreal Engine concepts. I am learning Unreal Engine from YouTube videos, and I am including the list of videos that taught me the concepts I've used in this solution. For ground locomotion, I first needed a level with a landscape in it that I could walk on. Here is the video that taught me how to build landscapes. When I'm on the ground, I want to 1. Be able to look around by moving my mouse. 2. I want to run around touching the ground with my feet, as in I don't want to leave the ground or go into the ground mesh. 3. I want to jump. 4. I want to toggle auto running so I don't have to hold down W to move forward all the time. And 5. I want to be able to take off and fly. I created an input action for each of these 5 things. For looking, moving, and jumping, I kept the input actions from the default third-person character blueprint. I ended up using the look and toggle auto-run input actions for all 4 locomotion types, because looking just moves the camera around when I move my mouse, so the outcome doesn't change depending on the context. Same for the toggle auto-run input action. I press the middle mouse button and my character starts moving forward. The code in the character blueprint handles the different movement styles here. So in my ground input mapping context, I have the 5 input actions I mentioned: look, move, jump, toggle auto-run, and take off. Look, move, and jump are the default settings from the third-person character project in Unreal Engine. I look with my mouse, I move with WASD, I jump with the spacebar. My toggle auto-run is the middle mouse button with no other additional settings. My takeoff is the right mouse button with no additional settings. This is my character blueprint, and we're in the event graph. This orange comment block here contains all the logic for the ground locomotion. I kept the default code from the third-person character blueprint because I liked its ground locomotion system and added the rest of the logic to it. Here, in Event Begin Play, the top half of this block is the default code. When it adds the mapping context, I set that to my ground mapping context because I always start the game on the ground. After that, I set the default values of variables that I use in this blueprint for the other locomotion types. I set auto-run to false because we start the game standing still. I set the environment enum to ground. I set the 2 variables for flying to their default values. We'll talk more about those when we discuss flying. And the last 2 nodes are just to display the current environment type in the lower right corner of the screen. This helps with showcasing and debugging. The look input action is the default code from the third-person character. It sets up the camera to let you look around your character. The movement input action is also the default code. This lets you move in the direction of the camera while sticking to the ground or water surface. For the toggle auto-run input action, we first check if we currently are auto-running. By default, we're not. We start the game standing still. So if we push the middle mouse button and start auto-running, we need to set our auto-run variable to true and then start a timer, which will move our character forward depending on the movement mode they are in. We set the time to 0.01 so that there is no wait time between pressing the button and starting the movement. we set it to looping, and we create the custom event which will move us forward. I could be using my environment variable here, but movement mode works fine too. Walking and falling for me count as the ground locomotion type, so I copy over the 3 nodes from the default movement code, which will move my character forward while sticking to the ground. When I'm in flying movement mode, which I am for the other 3 types, underwater, water surface, and air locomotion, I use the same default code for moving forward, but I also connect the Y value from the control rotation to the Y parameter of the forward vector. Y is the pitch, which is the up and down camera movement. This allows my character to go up and down as the camera moves in all directions. Jumping has the default code with no modifications. The taking off input action starts with a jump. This is because if I'm on the ground with my feet and I just start flying, my wings will clip through the ground and half my body will disappear into the ground when I will apply animations. So I want my character to leap into the air and start flying. So after this jump, I set the environment to air. I set my max flying speed to 7,000, which is the speed you gain when you dive. I need to set this every time you start flying because when swimming, I am also using the flying movement mode, and I don't want to go at a speed of 7,000 through the water. That's too fast. So whenever I enter the water, I set the maximum flying speed back to 800, which is also the minimum flying speed. After this, I set the movement mode to flying, and then I choose the flying input mapping context. Unreal Engine allows for multiple mapping contexts to be loaded at the same time and take effect, but in case of a collision, it uses the mapping context with the lowest priority first to resolve the collision. A collision refers to the same button mapped to do different things in different contexts. In my case, my right mouse button in the ground context means taking off and start flying, whereas in my flying context, it means stop flying and switch to ground locomotion. I don't want a static priority to decide which one will get resolved first, because I need the locomotion type to decide. So this is why when I add an input mapping context, I make sure to remove the other 3 so that there are never any collisions. In this case, I add the flying mapping context and remove the ground, water surface, and underwater mapping contexts. And this is everything for ground locomotion. For water locomotion, I first needed a body of water in my level to interact with. Here is the video that explains how to add water to a level for swimming locomotion and how to set it up. In a nutshell, we need 3 things to make water: a plane, a physics volume, and a post-processing volume. The plane with a water material is purely for aesthetics. My dragon looks nice poking out from the water, which is nothing more than my character clipping through the water plane. For my water material, I used the matte_clear_water from Synty's polygon-nature-pack. I also set this plane's collision presets to no collision, otherwise I walk on water like it's ground. The physics volume, which goes under the plane of water, has settings which will determine how much I slow down when I'm swimming in it. You can also use it to configure how slowly you sink to the bottom if you're not moving. I didn't want that mechanic in my game, so I'm not using it. I had to tweak the exact positioning of the physics volume under the water plane to make it such that my dragon's head, neck, and a bit of its back stick out of the water instead of just its head. And finally, you need a post-processing volume which overlaps with the physics volume, and it is another purely aesthetic component because this will determine what being underwater looks like. In my case, I chose for the light to be bluer, but you can do some fancier light tricks in here. For water surface locomotion, I want 1. To look around, 2. To move around while sticking to the surface of the water. If I look down and move forward, I don't want to go underwater. I want to remain at the surface. 3. I want to toggle auto run. And 4. I want to dive underwater. I am reusing the look, move, and toggle auto run input actions from the ground locomotion because they do the same thing in the water surface context. I only needed to create one new input action for diving underwater, which has the same settings as jump. Value type is bool, and it has two triggers, pressed and released. With that, my water surface input mapping context has 4 input actions. Look, move, and toggle auto run have the same settings as in the ground input mapping context. And diving underwater is assigned the right mouse button with no additional changes. Over in the character blueprint, this cyan colored comment block is where I have the logic for my water surface locomotion. First, we need to know when we are in the water. We do this by checking if our character overlaps with our water physics volume. We use the actor begin overlap event and then check to see that it's overlapping with our body of water and not something else. I should have given it a more suggestive name, but physics volume is what I left it at. If our character capsule overlaps with it, I want to capture the Z location of my character at the moment of impact and save it in a variable called water Z. This is how I calculate where the water surface is. Alternatively, I could compute the Z of this side of the physics volume cube and save that instead. Saving the character Z location at time of overlap can be buggy if I enter the water at a really high speed, something like 10,000, because then the reading will happen when I am already deeper underwater, and water Z will be lower than where it should be. So I end up swimming under the surface of the water, which is not what I want. We set our environment to water surface. We set the max flying speed to 800 because I am using the flying movement mode. This is because it felt better to control than the swimming movement mode. After that, I add the water surface mapping context and remove the other 3, ground, flying, and underwater mapping contexts. Next, we need to know when we're leaving the water. For this, I call the actor end overlap event to check if I'm no longer interacting with my water physics volume. I always assume that I'm leaving the water to get on ground, so I set the environment to ground. I set the movement mode to walking, and I add the ground mapping context and remove the other 3, flying, water surface, and underwater. For diving, I call my dive input action and set the environment to underwater. I set the max flying speed to 800 because I don't want to have the zoomies underwater. I set the movement mode to flying, and I add the underwater mapping context and remove the other 3, ground, flying, and water surface. And this is everything for water surface locomotion. When I am underwater, I want to 1. Look around, 2. Move around following the direction I'm looking in, so going left and right and up and down. I don't want to be stuck to a specific location on the z-axis like with the ground and water surface locomotion. 3. Toggle auto run. And 4. Stop swimming underwater and float back to the surface, switching to water surface locomotion mode. I am going to reuse the look and toggle auto run input actions like before. I am going to create a new input action for this new movement, which follows the direction of the mouse, including up and down, and call it Move 3D. I used the axis 3D vector value type, but I think 2D would have worked fine because in the blueprint I don't actually use the z-axis from this input action. I also created a new input action for stop diving, and I chose a bool with the pressed and released triggers, same setup as the jump input action. So my underwater input mapping context has the same settings for look and toggle auto run as before. For move 3D, I only included W to go forward. It's probably fine to include A and D to go left and right, but I don't want my character to turn around and swim towards the camera while it's supposed to follow the camera movement. I'm thinking of not supporting going backwards at all, or maybe I will support a slow back pedal. But for now I'm sticking with W only, which has the same settings as in the other mapping contexts. For stop diving, I have the right mouse button with no other settings. Back in the character blueprint, this inky blue comment block is where my underwater logic is. For the 3D movement, I copied over all the code from the ground movement, and the only difference is that when moving forward I also connect the Y value of the control rotation to the forward vector. The Y value is the pitch, which changes when I look up and down with the camera. You can see I don't use the z value from the input action, which makes me think it didn't need to be a 3D vector in the input action value type. To stop diving, I call the stop diving input action and set the environment to water surface. I set the movement mode to flying, I set the max flying speed to 800 so I don't have water surface zoomies, and then I add the water surface mapping context and remove the other three: ground, underwater, and flying. But this code here doesn't actually float me back to the surface. So to do that, we need to tap into event tick. Event tick runs every frame. The one I have here checks which environment I am in, and if it's the water surface environment, it will float me back to the water surface. If it's air, it figures out the speed changes to do the tricks I showed earlier, but I'll explain that when we talk about air locomotion. To float me back to the water surface, it checks to see if my character is under my water plane on the z-axis. I save the point I entered the water in the water z variable, and I subtract my character's z location from that. If the difference is greater than 8, it means I am underwater and I need to be brought back to the surface. Then I push my character up the z-axis by 5. I do this using set actor location to my current location, but adding 5 to the z value. I found 5 to be the right speed at which my dragon floats back to the surface by tweaking the value. Why did I pick 8 to be the difference between my character and water z? It makes my dragon stable in the water, and it is sticking out of the water with its head, neck, and a bit of its back, just like I want it to, no matter how I jump into the water. Again, I reached this value by tweaking and playing with it to see what works best. For example, if I use 0 instead of 8, in some situations I end up forever bouncing up and down because I increment my position by 5. And I end up exiting the water, which puts me in ground movement mode, which activates gravity on me, which plunges me back into the water, which determines that I am under the water level and pushes me back up, which causes me to exit the water, and so on. The loop continues, and my dragon ends up glitching up and down on the water edge. And this is everything for underwater locomotion. When I'm flying in the air, I want to 1. Look around, 2. Toggle auto run, 3. Move around in the direction of the camera, same as my underwater movement, and 4. Stop flying. I am reusing the existing look and toggle auto run input actions like before. I made a new input action for stop flying, which is a bool with no additional settings. And I thought I could reuse the move 3D input action from the underwater locomotion, but if I do that, I end up skidding a lot. I want to fly really fast, and so if I try to turn, my inertia is so great from the high speed that I keep moving in the original direction. This sliding was extreme, and it came from Unreal's default physics system. I tried to tweak it by playing with the various braking speeds and friction, but nothing worked, so it had to go. What I ended up doing was I created a separate input action called flying move speeding. I think precise flying would have been a better name, or no sliding flying. So my flying input mapping context has 4 things in it. The settings for look and toggle auto run are the same as the others. Stop flying is just the right mouse button with no additional changes, and flying move speeding is just W for the same reasons as the underwater movement. Back in the character blueprint, this white colored comment block has the logic for flying locomotion. To stop flying, I set the environment to ground, I set the movement mode to falling, and then I add the ground mapping context and remove the other 3, flying, underwater, and water surface. To move around in the air without sliding, I copied over the Move 3D code, which adds the 2 movement inputs, and after that I calculate and set my velocity vector. What is a velocity vector? It is a vector that contains both the direction and the speed at which my character is going. Unreal Engine calculates this under the hood using acceleration and friction and inertia, and because I couldn't figure out how to remove the inertia, I decided to calculate the velocity vector myself, only with the values that I wanted. This is a 3D vector, so it has 3 values, and I looked up the formula for how to calculate it, and I realized that I had all the information I needed in this block. The control rotation gives us the direction in which the camera is pointing, so I take the pitch, Y angle, and the yaw, z angle together with the speed I want to be going at, which is a variable that I called intended flying speed, and calculate the velocity vector. For cosinus and sinus, I use the degree version instead of radians because get control rotation gives us the angles in degrees. The speed comes from the intended flying speed, which we calculate in the event tick. When I stop moving, I want the intended flying speed to be reset to the minimum flying speed so that I don't shoot out of a gun from a standing position, and instead I have to build up my speed by diving. Coming back to our event tick, we saw that every frame I check what environment I am in. If we're in water surface mode, we float back to the surface. If we're in air locomotion mode, I only want my speed to change if I'm moving. So I check if my current speed, which is the length of the velocity vector, is greater than 0. If I'm moving, I want to increase the intended flying speed when I look down and decrease it when I look up. To figure out where I'm looking, I get the camera angles from get control rotation and check the pitch. If I look straight ahead, the value is 0 or 360. If I start looking up, the value climbs from 0 to 90 at its highest. And if I start looking down, the value goes from 360 to 270 at the lowest. So I chose to increase the speed if I'm looking downwards between 270 and 350. And I decrease the speed if I'm looking upwards between 20 and 90 degrees. If I'm looking straight ahead, my speed does not change. So it is possible right now to dive to speed up and then fly straight, and you don't lose any speed because I don't have any friction implemented. It's not realistic, but it is very fun in game. I also need an additional check when I'm changing the intended speed. I don't want to go past the maximum flying speed if I'm diving, and I don't want to slow to a halt if I'm flying up. So before I speed up, in addition to checking that I'm looking downwards, I'm also checking that the intended speed is less than the maximum flying speed. Otherwise, the game gets out of control quickly. Same thing for decreasing the speed. I check that I'm looking upwards, and then I check that the intended flying speed is greater than the minimum flying speed. As for the actual speed change, I found that plus 80 for speeding up and minus 40 for slowing down every frame gets a fun feel for flying. I might change these values for more complex logic, but for now they'll do. One funny thing that happened after I implemented this flying mechanic was that if I sped up in flight and then I clicked the right mouse button to stop flying, that switched me to ground locomotion and Unreal Engine's physics system kicked back in. I already had a high speed, so I ended up sliding across the entire level map before I came to a halt or fell in the water or slammed into a cliff. To prevent this, I changed the character's braking friction from 0 to 1.4. You can find this setting in your character blueprint in the viewport by selecting the root of the class, self, in Window Components, and the property you can find it in Window Details. Go to the Character Movement General Settings area, and then the name of the property is Braking Friction. With this setting, I now only skid a little, which gives space for some cool skidding animations that send pebbles flying and kicks up some dust clouds as I slide to a halt on the ground. It also reduces the amount of sliding in the other locomotion systems. And that is everything for air locomotion. As I was building this locomotion system, it really helped that I worked on one environment at a time and made changes to existing code as needed instead of trying to build everything at once. It also helped a ton that I didn't try to add animations at the same time like a lot of tutorials have you do. Keeping the movement logic separate from the animation logic helped me better understand how my code worked in Unreal. And this was my solution for the locomotion system that I wanted. I'm so happy I figured it out so I can have fun with my air zoomies now, and I can't wait to add animations to this thing.